Hello everyone, my name is Naomi Fossa, and I go to a homeschool co-op called Excelsior in Allentown, Pennsylvania. This year I decided to enter a science project into my school's science fair about calorimetry. I got the idea from my chemistry class when we did a simple calorimetry experiment, and I began to think about what would happen if I applied that experimental process to different materials. In the end, I ended up getting first place, and my chemistry teacher, Mrs. Godel, suggested that I give a presentation to you all today. Before I get into the details of my experiment, I should go over some definitions. First of all, what is calorimetry? Calorimetry is an experimental process used by chemists to measure things like heat transfer, specific heat, and the temperature of chemical reactions and physical changes. My project focuses on specific heat. Specific heat is the amount of energy needed to raise 1 gram of a given material by 1 degree Celsius. Every single object on Earth has its own unique specific heat, so this is a really cool thing to learn. Another important thing in my experiment is the conservation of energy. That's the law that energy cannot be created or destroyed, it can only change form and be transferred from one place to another. The purpose of my experiment was to demonstrate through experimentation the process of calorimetry and to learn hands-on about the process and to compare the specific heats of my different materials. I chose glass, wood, and metal. In my experiment, I predicted that metal would have the lowest specific heat, meaning it would take the least amount of energy to build, set glass the second lowest, and wood the highest. Before experimenting started, I measured and recorded the mass in grams of my calorimeter, which is just the device used to keep heat from leaving the experiment, my samples, and the water on my calorimeter. I also recorded the room temperature that I was working in. First, I heated water in a pan to 100 degrees Celsius or until it was boiling vigorously. Then I dropped one of my samples into the water and let it boil for 5 minutes. This raised the sample's temperature up to 100 degrees. I was then able to take that sample and drop it into my calorimeter filled with water. And because of the conservation of energy, the water and calorimeter heat that was in the sample transferred to those until they were all the same temperature. I recorded this by stirring the water and the sample in my calorimeter with a thermometer, and once it reached the highest temperature it would, I recorded that temperature. Then it was easy to plug the numbers into my equations and calculate the specific heat. Also, I did that procedure about 3 times with each material. The main equation I used is Q equals M times C times delta T. Q means heat in joules, M means mass in grams, C is what stands for specific heat, and delta T is change in temperature. The first thing I had to calculate was the change in temperature. This was pretty easy. All I had to do was subtract the initial temperature, which was just the temperature of the room I was working in, from the final temperature, which is what I recorded on my thermometer at the end of my experiment. Then I used the original equation to calculate the amount of energy absorbed by the water during the experiment. After that, I could use the second equation listed. The negative heat in joules of the sample is equal to the heat in joules of the water plus the heat in joules of the calorimeter. Since I already had the heat in joules of the water and the heat in joules of the calorimeter, I was able to find the heat lost from the sample when heat was transferred to those two things. Then I just rearranged the original equation, and since I had all the other factors, I was able to calculate the specific heat. These are my calculations. And in the end, glass had the lowest specific heat, metal had the second lowest, and wood had the highest. Unfortunately, this is contrary to my hypothesis and official scientific findings. I looked back at my experiment and I found some mistakes. My hypothesis stands true in real life, but something happened in the experiment that messed that up. First of all, I had 3 thermometers that weren't quite accurate. My first mistake was using 3 of them. Second of all, I placed them all in water and put a heated sample into the water and watched, and they rose at slightly different rates and started at different temperatures. Next time I do this experiment, I'll use just 1 thermometer. Second of all, I had exploding glass, so about the 3rd time I tried running through this experiment, my glass actually exploded in my calorimeter, and I did my best to collect the shards, but I know some must have escaped, which would affect the mass of my glass and then the rest of the equation. That might have been the reason glass had the lowest specific heat, because then it would take less energy to heat up all of it. Lastly, I had low quality calorimeters. They were just two styrofoam cups stuck together, which can't really compare to the official calorimeters, professional scientists use. But in the end, the purpose of my experiment was still achieved. I still learned hands-on about the process of calorimetry, and I was still able to compare and contrast the results I got. I also learned one last valuable lesson, which is that sometimes we need to work through initial failure to reach ultimate success. Thank you.